examples on impulse and application of conservation of linear momentum. Look at this first example. Question says that a ball of 2 kg is dropped from a height of 20 meters on a horizontal surface. It hits the ground or the surface and then rebounds such that it again reaches same height h. It was in contact with the ground for 0.01 seconds. Question is, find out force exerted by the ground on the ball. Write down the question. Find out force exerted by the ground. Find out force exerted by the ground on the ball during the collision. Now, how do we handle this question? We know that F is dP upon dt. When this ball collides with this surface, at that time what is happening? Look here. This is the ball and it is in contact with this surface. If it is in contact with the surface, then a normal reaction force will act on the ball. Normal reaction N. This N, you know, is always perpendicular to the contact surface and towards the body. Horizontal surface is exerting a force N on this ball. At the same time, gravitational force mg is also acting on this ball downwards. This is during collision. Now, in second law, when you write F equals to dP by dt, you know that this F is what? Total force. What is total force on this ball? Total force on the ball is N minus mg. N minus mg. Why not mg minus n? Because we know that n is greater than mg. And how do we know this? You can see that ball is coming down, and then once it comes in contact with the ground, it bounces back because of this force N. Now, suppose you say that mg is greater than n, then net force on the ball will still be what? Downwards. Ball is falling down. If you say that mg is greater than n, then net force is again what? Downwards, and therefore this ball will continue moving down. Again, ऐसा हो नहीं रहा है. Bounces back. If it bounces back, you're changing direction of motion, and that is possible only if you say that n is greater than mg, and therefore total force on the ball at this time is what? N minus mg. What is N minus mg? dp by dt. What is dp by dt? dp is p final minus p initial divided by dt. What does it mean? This much linear momentum should change. P final minus P initial. This is the change in linear momentum. And this change in linear momentum took place in what time? dt. Then ratio of dp and dt is called what? Force. फिर से सुनना. This much change in linear momentum took place in what time? dt. If you take the ratio, you will get the force which changed this linear momentum. Linear momentum के change को time से divide किया, जो force मिला वो force है जिसने dp का change develop किया था. That's what second law says. Now, हमारे केस में net force अपने को पता है. We need to find P final minus P initial. ये P final minus P initial क्या है? P initial just before the impact linear momentum. After time dt, जो collision time था वो कितना था? dt. After time dt, जो linear momentum है वो कितना है? P final. Initial and final का मतलब ये नहीं है कि ये initial है और ये final point है. नहीं. Initial and final, these two times are separated by a time gap of dt. What is P final? We can write mv final, mv initial divided by 0.01 dt. That is given in the question. Now, from kinematics we know that if you drop something from height of h, then its velocity is given by this formula, root over 2gh, which means इस situation में v is coming 2, g is 10, h is 20, v is therefore coming 20 meters per second. अब अगर ये 20 से टकराएगा and then bounces back to the same height, because question says so, that means just after this impact, this collision, its velocity should be again 20 meters per second. From rest, it develops a velocity of root 2gh, which is 20, and then from 20, after moving a distance of h, it finally comes at rest. Now, V final, mass is given 2 kg, final velocity is what? 20 minus mass. Initial velocity, remember, is not 20. Initial velocity is what? Downwards. If velocity is downwards, that means you must take what? Minus of 20 divided by 0.01, which is coming 40 minus plus 80 upon 0.01 or 8,000 newtons. What is 8,000 newton? Total force. But what is total force? N minus mg. What is N minus mg coming? 8,000. M is 2, G is 10. That's all 8,000. It gives us N as 8,020 newtons. This is the impulsive force which acted on this ball when it was in contact with the ground. This N is impulsive normal reaction or impulsive force. Impulsive normal reaction force. What do I mean by impulsive normal reaction force? यहां देखना. Suppose आपको एक situation इस तरह की दी होती that we have this ball and this ball of same mass 2 kg simply lying on the ground. Ball is lying at rest on the ground. There is no movement. Situation is like this. A ball is simply lying on the ground. In this case, again there will be a normal reaction force. Let's call it N dash. Just to differentiate from this normal reaction force, let's call it N dash. Again, downward force of mg is present. Ball is at rest and therefore N dash should be what? mg, which is what? 20. This N dash is not an impulsive force. Impulsive forces कितनी देर के लिए लगते हैं? For a very small time interval. This N acted on the block only for what time interval? 0.01 second. And therefore this N is your impulsive normal reaction force. Whereas this N dash is continuously acting on the ball. And therefore remember, this N dash is not an impulsive force. अब when we discussed impulse and all, तो हमने एक स्टेटमेंट यूज किया था. वो स्टेटमेंट क्या था? Impulsive forces are normally very large. Same ball, if it is in contact with the ground, is not moving, is at rest, then normal reaction force, its magnitude you can see is what? 20. But when same normal reaction force becomes impulsive, look at the magnitude, 8020. You can see that 8020 is quite large, and therefore we always say that impulsive forces are relatively very large. अब इस large and all की वजह से in competitive examinations at times you will find something like this. If they ask for this normal reaction force which acted on this ball for this time gap, then they can simply do this. F dt dp, dp is coming 80, dp is coming what? 80. F, they consider F as N only. dt we can see 0.01 80, and they will say that N is 8000. What happened in this situation? Correct answer for N is this. But many a times, since this 8000 or this normal reaction force, N is simply much larger than what? mg. N is much larger than what? mg. N minus mg लोग इसको approximately क्या बोल देते हैं n, and once they do this you will get the value of n as what, 8000 Newton. क्या किया उन्होंने बोला कि यार ये mg बहुत छोटा है. कितना छोटा है देखना इसको. सपोज किसी आदमी ने बोला होता है ये 0.01 की जगह पर 0.001 होता. Had it been 0.001, then this thing will not be 8000. This thing will become what? 80,000. If this is 80,000, this is 80,000, your n in that case would be 80,020. 80,020. ट्रिक के लिए कई बार कॉम्पिटिटिव एग्जामिनेशंस में आपको ऐसा दिखेगा that instead of writing 80,020 they give you this option only. Now if in a given competitive examination you found that there are two options, one is 80,000, at the same time there is an option which says 80,020. If examiner is looking for this much minute thing, then remember correct answer is what, 80,020. But if options are like 80,000, 60,000, 70,000, that means examiner को क्या चाहिए? He wants you to neglect this mg part and focus only on what? Impulsive force, which is what, n. I hope you can see that mg fundamentally is not an impulsive force. mg is continuously acting on the body. और जो n था ये केवल किस वक्त लगा था? ड्यूरिंग कोलिजन. ड्यूरिंग कोलिजन मींस कितनी देर के लिए? 0.01 सेकेंड. And therefore n is an impulsive force. mg is not an impulsive force. Similarly n dash, it is also not an impulsive force because ये continuously act कर रहा है. Impulsive forces क्या होते हैं? जो एक instant के लिए लगे, just like this normal reaction which we just had in this example. Now यहां जो मैंने trick part समझाया हुआ है, this is basically for competitive examinations as a shortcut कि पूरी डिटेलिंग की जरूरत ना पड़े. आप डीपी फाइंड करो, टाइम से डिवाइड कर दो, यू गॉट द फोर्स. बट रिमेंबर दिस आंसर इज जस्ट एन अप्रोक्सीमेशन. करेक्ट आंसर इन स्कूल्स एंड ऑल, if they ask you this question, then you must write n minus mg. होपफुली समझ में आया होगा क्या पॉइंट यहां पर मैंने समझाया है आपको. Note down this. Let's understand difference between normal forces and impulsive forces. Normal means not normal reaction forces. Normal situation में जो force लगता है और impulsive situation में जो force लगता है. Consider this example. A block of 4 kg is hanging with the help of this massless rope and is connected to this rigid support. इस वक्त मैंने आपसे पूछा होता कि भाई बताओ 4 kg में कितना टेंशन फोर्स है, तो आप क्या करते? टेंशन फोर्स T अप, डाउनवर्ड फोर्स mg. 4 kg is simply hanging at rest and therefore you will say that T is 40. T is 4g. This is strength of tension force for this setup in normal situation. Now, take this situation. Same setup. Let's say this height is 5 meters. Length of rope is what? 5 meters. And what we did, we raised this block of 4 kg from this position to this position. When you do this, you can see that this rope will simply collapse. As it collapses, tension force in this rope is now what? 0. उठाकर यहां कर दिया हमने. Tension force कितना हो गया? 0. Now you drop it. And question says, once you drop it, it looks like this. Once you drop it, this 4 kg block, you have dropped it for this height of 5 meters, and therefore it has gained a velocity of root 2gh, which is 2 tan 5 is coming 10 meters per second. This 4 kg, when you dropped it, just when rope is taut again, it gains tension force. Just before that, 4 kg is moving with what? 10 meters per second. And then what we found that this 4 kg in just 0.01 second came to rest. Why? Because of this rope. इस rope ने क्या किया? एक impulsive tension force लगाया. Impulsive tension force T dash. This T dash is impulsive. ये impulsive tension force कितनी देर के लिए लगा? 0.01 सेकेंड. And after 0.01 second, इसने इस 4 kg ब्लॉक को रेस्ट पर लाकर खड़ा कर दिया. यहां this 4 kg is now at rest. क्या हुआ? फिर से देखना. Suppose this setup at this location, we say that time is t. From this to this, a time gap of dt is present, and therefore time will be t plus dt. हमें सबकी जरूरत नहीं है t and all की, केवल समझने के लिए. टाइम t पर ये चीज 4 kg 10 meters per second से मूव कर रहा था. Rope is about to get the tension force T dash. जैसे ही रोप ने टेंशन फोर्स डेवलप की, कितनी देर के अंदर dt 4 kg comes to rest after that. अगर हमसे पूछा जाए find out tension force now, then I hope you can see this is same as this setup. 4 kg at rest, and therefore tension force is again what? 40. लेकिन यहां क्या हो रहा था? यहां से यहां के बीच में क्या हो रहा था? यहां से यहां के बीच में एक इम्पल्सिव टेंशन फोर्स लगा और उस इम्पल्सिव टेंशन फोर्स ने 4 kg की वेलोसिटी को 10 मीटर्स पर सेकेंड से जीरो कर दिया। अपने को ये इम्पल्सिव टेंशन फोर्स फाइंड करना है। हमने क्या किया, हमने लिखा F is what dp divided by dt. What is net force? Net force on this 4 kg. Downward force is what? 4g. T dash minus 4g. This is the net force. What is dp? P final minus P initial upon dt. It's given 0.01. Net force is T dash minus 4g. P final rest minus P initial. What is P initial? P initial is what? 4 kg is moving with what? 10. 4 kg is moving with 10 but downwards, therefore minus of 10. Divided by dt 0.01. This is coming T dash minus 40 equals to what? That is minus minus plus 40 upon this is 4000. T dash is 4040 newtons. What is T dash? Impulsive force. What is T dash? Impulsive force. Impulsive forces normally क्या हुआ करते हैं? Large. इस सिचुएशन में टेंशन फोर्स क्या था? 40. जब ये इंपल्सिव टेंशन फोर्स बन गया, उसकी स्ट्रेंथ क्या हो गई है? 4040. कितनी देर के लिए हुआ है ये सब? फॉर टाइम इंटरवल dt, which is given as what? 0.01. Up. As I told you, many a times you can find that they simply give us T dash as 4000. Why? Because they will take this fact into consideration that T dash is much larger than mg. जो अपना इम्पल्सिव फोर्स है ये बहुत ज्यादा है। अगर हमारा T डैश mg से ज्यादा है तो फिर कई बार T डैश माइनस 4g कैन बी अप्रोक्सीमेटेड बाय T डैश। जैसे ही आपने इसे T डैश से अप्रोक्सीमेट किया, in that situation your answer will be what? 4000. If in a school examination they give you the value of time and each and everything like this, then proper way is to answer the question using total force in this form T dash minus 4g. In an objective question paper, if you see that this option is not there and only 4000 is present, then it means they are assuming that tension force, impulsive tension force, is much larger than the gravitational force mg, and therefore mg can be neglected. इस एग्जाम्पल से क्या होता है नॉर्मल सिचुएशन में फोर्स, क्या होता है इंपल्स वाली सिचुएशन में फोर्स। जिस वक्त इंपल्स लग रहा था, इंपल्स उस वक्त का टेंशन का बिहेवियर होपफुली समझ में आ गया होगा। नोट डाउन दिस। Now look at this example. There are two blocks of 2 kg and 3 kg, connected by a massless rope, and there is no friction anywhere. Friction is 0. There is no friction. There is no friction between pulley and rope. We have already done questions like this. We can find acceleration, we can find tension, force and all. If you remember, tension, force for this type of system and acceleration for this type of system, we used to calculate like this. What is the acceleration? What is the pulling force? 20. 2g. And this force is pulling what? 2 as well as 3. Acceleration is coming 4 meters per second square. What was the tension force? What was the tension force in this type of setup? Let's say T dash. T dash. What was T dash? Mass into acceleration. Mass is what? 3. Acceleration is what? 4. It is coming what? 12 newtons. T dash is coming down with A. It's moving in this direction with A acceleration. Pulling force is what? 2g. And this 2g, which is 20, is pulling what? 2 plus 3. If you remember, we had a shortcut for this. We used to say that this whole setup is fundamentally equivalent to this. As if there are two blocks of 2 kg and 3 kg, and they are being pulled in this direction with a force of 2g. T dash, T dash, they are what? Internal forces. 2g is pulling what? 5. ये अपन कर चुके हैं, हम इसमें इंटरेस्टेड नहीं हैं. हम किस चीज में इंटरेस्टेड हैं उसको देखना. अपने को क्वेश्चन दिया that the same thing, same setup, 3 kg rope, but this rope is right now loose. This 2 kg block has been lifted up. Let's say this length, suppose this length is 5 meters. Suppose this length is what? 5 meters. The question says that somebody has lifted this 2 kg block to this height and then he drops it. If I raise this 2 kg block 5 meter and then if I drop it, then we need to find velocity of this system just after rope is again taut. That means it has gained some tension force. Listen again. I hope you can visualize this much. If I raise this 2 kg block from this position to this position, then rope will simply collapse. And as this rope collapses, there is no tension force in this rope right now. As of now, इस rope के अंदर टेंशन फोर्स क्या बना हुआ है? 0. हमारा 2 kg ब्लॉक कितना हमने इसको लिफ्ट किया हुआ है? 5 meters. Now, when you drop this 2 kg, as it falls, The moment this height is again what 5 meter, you can feel that this rope again becomes taut. It gains what tension force. Just after gaining tension force, we need to find velocity of 2 kg and 3 kg. Write down the question. 2 kg is raised by 5 meters. 2 kg block is raised by 5 meters and then is dropped and then is dropped. Find out velocities of 2 kg and 3 kg blocks. Find out velocities of 2 kg and 3 kg blocks just after rope is again taut. Now, why do we have this question under this category? कोशिश करना फील करने की इम्पल्स यहां पर क्या है, इम्पल्स किसका इम्पल्स लग रहा है, ये सोचने की कोशिश करना. यू कैन इनफैक्ट pause the video, think about it, and then come back and see the solution. जैसे ही आपने इस ब्लॉक को रिलीज किया, the moment it covers this height of 5 meters, this distance of 5 meters, the setup will look like this. The setup will look like this. Rope is again taut, and now tension force, let's say, is T double dash. T dash इस सिचुएशन का था. T स्टार्टिंग में 0 था. जैसे ही ये ब्लॉक यहां पहुंचा, टेंशन फोर्स कितनी हो गई है? T double dash. Now what I want you to visualize is this. This T double dash is an impulsive force. Impulsive force. Whereas this T dash is not an impulsive force. Is not an impulsive force. ये T dash इस पूरे ब्लॉक सिस्टम पर केवल dt टाइम के लिए एक्ट करेगी. जैसे ही ये रोप एक बार टेंशन डेवलप कर लेगी, is again taut. Immediately afterwards, tension force in this rope will be this T dash. लेकिन जिस वक्त ये जर्क लगा था, I hope you can feel this word jerk. अगर आप इस रोप को फ्री हैंड को अपने हाथ में रखो, ब्लॉक को हैंग करो, रेज इट अप एंड देन ड्रॉप इट. जैसे ही ये रोप लेंथ के इक्वल नीचे आएगा, आपको इस रोप में एक झटके से टेंशन फोर्स डेवलप होता हुआ दिखेगा. दैट jerking tension force is basically impulsive tension force, and I have told you that this T dash is much larger than this type of tension force, because impulsive forces are normally very large. अब इस बार क्वेश्चन में अपने को ये नहीं दिया है कि भाई कितनी देर के लिए ये इम्पल्सिव रिएक्शन फोर्स एक्ट कर रहा था, बिकॉज इट्स एक्सट्रीमली डिफिकल्ट टू मेजर दैट टाइम एंड हमें उसकी जरूरत भी नहीं है। इफ वी टेक केयर ऑफ दिस फैक्ट, किस तरह से देखना, दिस 3 kg is at rest, 2 kg is released from this position and then is dropped and covers a distance of 5 meters. तो जैसे ही ये सिस्टम यहां पहुंचेगा, इसके पास एक वेलोसिटी डेवलप हो गई है which is root over 2gh, which is root over 2gh and is coming 10 meters per second. कब हुआ है ऐसा? जब अपना 2 kg ब्लॉक कितनी डिस्टेंस ट्रेवल कर चुका है? 5 मीटर्स। रोप टेंशन फोर्स डेवलप करने के जस्ट पहले ये सिचुएशन है। 2 kg is moving with 10 meters per second. 3 kg is still at rest. Let's say this whole setup is drawn at time t. टाइम t पर ये कहानी थी। रेस्ट पर 2 kg ने कितनी वेलोसिटी डेवलप कर ली है? 10 meters per second. Then at t plus dt टाइम, इसका मतलब इस सेटअप से कितनी देर बाद dt टाइम के बाद क्या हो रहा है? dt टाइम के बाद क्या हुआ उसको देखना। जैसे ही रोप टेंशन फोर्स डेवलप करेगी, this 2 kg block is moving downwards with velocity v, and since now this rope has got a tension force, this 3 kg must also move with same velocity v, and question is asking you find out v. फिर से इतने पार्ट को समझने की कोशिश करना। क्या समझना है? जैसे ही हमने इस 2 kg को लिफ्ट किया, वैसे ही इस रोप के अंदर टेंशन फोर्स कितनी हो चुकी है? 0. देन व्हेन यू ड्रॉप होने के बाद 5 meters ड्रॉप होने के बाद इस 2 kg के पास वेलोसिटी आ चुकी है कितनी? 10. 3 kg is still at rest. Now imagine a situation like this. This body is moving. This is at rest. They are connected by a rope. If this rope develops a tension force, then that tension force will act for only a time interval of dt as an impulsive tension force, and that impulsive tension force is what? T double dash. Once dt time is over, once this dt time is over, after time dt, if you ask me what is the tension force, then I will say that T dash. सिचुएशन क्या हो चुकी है? फिर से नॉर्मल सिचुएशन डेवलप हो चुकी है। अब हमारा क्वेश्चन है फाइंड आउट v। किस तरह से फाइंड करेंगे इस v को सीखना है यहां पर 2 and 3 एंड इस 2 पर एक डाउनवर्ड फोर्स है mg, इस 3 पर टेंशन फोर्स है T डबल डैश। अगर ऐसा हो रहा है तो ये पूरा का पूरा सेटअप इसके इक्विवेलेंट है। T डबल डैश T double dash. There's a force of 2G, and this whole setup we are interested in it for what time interval? dt only. इस 2G को हमने बोला हुआ है this is much smaller than what? Impulsive tension force, and because of that we can say that on this whole setup there is no external force, and if there is no external force we can use what? Conservation of linear momentum. Conservation of linear momentum says what? P initial is equal to what? P final. Just before dt means at this setup, what is P initial? 2 is moving with what? 10. 2 is moving with 10. 3 is at rest. 3 is at rest. And just after time dt, they both are moving with velocity v. They both are, which means what? What is the total mass now? 5 is moving with what? v. This gives us v as 20 upon 5 or 4 meters per second, which is the answer for the question. जैसे ही this impulsive force acted on this block system, after time dt, velocity acquired is what? 4 meters per second. क्यों हो गया 4? फील करते हैं। इंपल्सिव टेंशन फोर्स लगने के जस्ट पहले इसकी वेलोसिटी कितनी है? 10। इसकी वेलोसिटी कितनी है? 0। उस इंपल्सिव फोर्स ने इस 2 की वेलोसिटी को 10 से डिक्रीज किया। It was moving downwards. Impulsive force acted up, and therefore velocity decreased from 10 to what? 4. This thing was at rest, and therefore tension force, impulsive tension force, increased its velocity from 0 to what? 4. They both must move with same velocity because now they are connected by this rope. In this setup, when you had raised this thing, rope was loose. If this thing is loose, this 2 kg, as long as it is above this height level, this level, right here, rope is still what? Loose. If rope is loose, 3 kg is not going to move. It will move just when this rope is again taut. अच्छा क्वेश्चन है इंपल्सिव फोर्स एज वेल एज COLM दोनों की एप्लीकेशन के लिए। नोट डाउन दिस।